Everybody, this is Mr. Munson, and it is Chapter 5, Triangle Relationships. This is concept number 2, special triangle segments. So we have 5 special triangles, or special segments, that you're going to need to just memorize what they are and their characteristics. They're not hard, though. If you just pay attention, stay focused, take good notes, practice with me. All right, here we go. First up, angle bisector. So in blue at the top there, you can see our I can statement for this concept is I can identify special segments inside triangles. So right now we're just identifying what those special segments are, and then you'll have to be able to identify them on your own, given them in a triangle. Okay, so angle bisector, a line that bisects an angle into 2 congruent parts. That's simple enough. As you can see the red line there, it bisects an angle. So if this was an angle bisector, which it is, I would identify those 2 angles as being congruent. Okay, so let's look at some of the characteristics of an angle bisector. All right, first up, it creates 2 congruent angles. That's what an angle bisector should do. Each angle has its own. What I mean by that is in a triangle, there are 3 angles. Each one of those angles has its own angle bisector. So there's 3 angle bisectors. They all meet at one point, and really interesting, they create a proportion that we want to be able to identify, and this proportion is a relationship. That means it's something that equals something else. Okay, so let's move on and take a look at that proportion. So as you can see in this picture, when I create this angle bisector, it creates 4 distinct pieces out of that triangle. Okay, so going from A to B, capital A to capital B, creates a small segment, or a small letter segment called A. And I could use any letters I want, K, L, T's, or whatever. So these letters I'm choosing are not related to the angles. They're just placeholders for length. So take a look at the proportion. I have A over B is equal to C over D. So you have to remember what a proportion is. Remember, when we set up proportions, once we got the pieces in place, we cross multiply to solve those kind of things. We've done that in the past. Okay, so we'll take a look at an example of that later on. Don't lose that proportion because you're going to need it to do your try it problem. All right, let's head back up to the original drawing. And I just want to draw the angle bisectors for each one of these. Okay, so I'm just going to draw that angle bisector. I'm just freestyling it for right now. And so there's the other angle bisector. Let's move it down a little bit because I kind of messed it up. Let's just move it down. There we go. And for the most part, hopefully you can see that's a pretty decent angle bisector, close enough. You can see that they all meet at one point. All right, let's move on. Next up, a median. A median connects an angle's vertex, in this case vertex B, right, that's the angle, the vertex, to a midpoint on a side opposite the angle. So D is the midpoint. We find that D is a point that bisects the segment AC into 2 congruent smaller parts. In this case, AD and DC. Okay, great. So that's called a median. Let's look at the character. Well, they bisect a side. That's the most important characteristic. Each angle has its own median. So C has a median that connects to a midpoint of segment AB, and so on. Okay, so there's 3 of these things, and they all meet at one point. Let's take a look at, there we have it, 3 medians. All right, next up, altitude, height of a triangle from a vertex to the side opposite the vertex. So I always like to think about it, if I was standing at B and I jumped from B, I'd fall straight down to the side opposite B. Okay, that's called the altitude. So it's a straight line that goes down and forms a 90-degree angle. It doesn't necessarily bisect that other side. It just simply is perpendicular. Here's the characteristics. It's perpendicular to a side. That's the main thing. Okay, each angle has its own altitude. Okay, and then it's known as the height of the triangle, distance from one of the vertex to the opposite side. So what we can do is take a look at finding the altitude for all 3 angles, so you can kind of see how to work this. So let's just freehand this. So I'm just going to draw a perpendicular here. Cool, and that's one of the altitudes. I find it helpful to rotate my figures so I can kind of look at it. So I'm going to take the side BC and just going to make it horizontal, like it's the floor of my drawing. Okay, so now I'm going to jump from A, and of course if I jump from A, I'm not going to jump sideways. That's not going to happen. I'm just going to jump straight down. So here's the problem. Because I jump from A straight down, I'm going to not land on side CB. No worries. The way we do this is we extend the side out for me to land on. Okay, so I'll just come straight down, and there's the altitude for that triangle. Again, it's how high is A from the floor of CB when I rotate it like this. Okay, let's do the next one. So again, I'll take it and, whoops, yep, there we go. Take it and rotate it so that the C is the last point that doesn't have a altitude from it. So I'll just rotate it until the floor AB is nice and horizontal for me. And then I'm going to draw its altitude. And there I have it. So the problem solving skill I want you to know is it's so much easier to rotate this thing so I create a floor and have the vertex I'm going to draw it from above it. Okay, and sometimes you're going to have to extend the side. In the case of BD, I didn't have to extend the side at all. It just simply fell right to the floor. All right, so as I promised, all three of these will intersect at the same place. Let me just extend these and see what happens. And there I have it. All freehand, pretty close. Cool. Now notice this point is outside the circle or outside the triangle. That'll occasionally happen. Next up, perpendicular bisector. I love this one because it has two characteristics and it's right there in the name. Perpendicular bisector. So it's going to be perpendicular to a side and it bisects that side. A line perpendicular to a side and bisects the side into two congruent parts. Now this doesn't have anything to do with the vertices. It's just simply a line that's perpendicular. So, I might pull out a ruler or something. I find that this is the midpoint. I'll just mark it as being perpendicular, or a bisector, and then I'll put in a perpendicular line, and there's my perpendicular bisector. Every side has a perpendicular bisector. Let's take a look at the characteristics. So, characteristics: bisects a side, perpendicular to a side. Each side has its own, not angle. Each side has its own. There's three of these, and they all meet at one point. So it's just easier for me to take my drawing and rotate it. So, if this was your paper, then you just rotate the paper. I'm just going to rotate it so like my visual is that the side I'm working on is horizontal. It doesn't have to be done this way. Okay, it's just easier for me. So I'll find the midpoint. That looks pretty good. We'll mark it congruent, and I'll draw myself a perpendicular bisector. Very cool. Now let's rotate for the next side. Oops. All right, here we go. Let's see, we already have, no, we don't have this side. AB is the side that we're waiting on doing. So here we go. Find the center of this thing, eyeballing it pretty good, mark it, and draw myself a perpendicular. And there's my perpendicular bisector. So I can see that they all are going to meet out here where the green and the red are already on their way. So let me get the purple one out there. And there they are. All three meeting outside this time. All right, let's move on. All right, the last of our special segment is the mid-segment. It connects two midpoints of a triangle. So each side has its own midpoint, right? So we'll just find the midpoints of those two. We'll find the other one for AD, or AC in just a bit. And so if I connect those two midpoints, I create a mid-segment. All right, let's take a look at the characteristics. All right, so bisects the side into two congruent parts. Okay, we each two sides. Sorry, I have a letter missing there. Each two sides have their own mid-segment. Okay, and we'll look at that in just a second. The mid-segment is parallel to the third side. Okay, very cool. So this is what I know. That mid-segment right there is parallel to the third side. It's the one that it's not at all touching. Once we have that those lines are parallel, then we can start talking about parallel lines cut by a transversal, right? So we can look at those angles right here and realize, hey, those are consecutive interior angles and they should be supplementary. And we'll just play with that. All right, let's find the other midpoint, make these connections here. So that looks pretty good. That looks about halfway in between. And so here's one mid-segment, another mid-segment, here's another mid-segment, okay? Now, interesting enough, you'll see that the three do not intersect, okay? But again, it creates some parallel lines. So this parallel line right here, that line right there is parallel to this one. And this one is parallel to that one. Okay, so these drawings can have their, complicatedness and everything, but that's no worries. Let's move on. All right, we're going to go through and just write some equations, make sure we understand some of these properties. So here we have an angle bisector. AD is an angle bisector. So I've got, I'm sorry, let me just fix this real quick. This should be A here, and this should be C there. So I apologize for that. And so AD is an angle bisector. So what that tells me is that that angle right here is congruent. This angle right here is congruent to that angle right there. So I can just simply write 3x plus 5 equals 4x minus 10. All right, so those two pieces are equal to each other. Let's move on to the next one. Given AD is a median, so we have to remember what a median is. A median bisects a segment into two congruent parts, okay? It has nothing to do with the angle other than it comes from it, okay? So when that happens, we know that it actually creates an equation, a relationship between those two pieces. So the equation in this case is going to be 3x plus 5 equals 2x minus 10. Notice I did not use this. It's unnecessary. It's a distractor. Let's go on to the next one. Given AD is an altitude, write an equation. So I have to remember what an altitude is. An altitude is something that comes from a vertex and is perpendicular to the opposite side. So I know that that angle 2x plus 5 is that side. So since it's perpendicular, we know that 2x plus 5 should equal 90 degrees because all perpendicular lines form a right angle. Let's move on to the next one. Given AD is a perpendicular bisector, write an equation to solve for x and y. Man, a bunch of stuff here, so we have to decipher this, okay? Let's start with trying to find x. So as I look down here, I see a perpendicular bisector. I know that it bisects it. It's already marked for me, but in case it wasn't, I could just mark that. So this is what I know. I know that 4x plus 5 is just one side of that from J to D. But it takes two of those. Another one would be over here. So I could write these two equations. I could write this one, 4x plus 5. Two of those makes the entire length of 29, as it stated, JL equals 29. Or I could do it this way. I just start off with saying that two of those is always equal to the longer one of 29. Okay? Either way, distribute it through to solve that kind of equation. We're not solving today. We're just simply writing them right now. Okay, given AD is a mid-segment. So mid-segment, I know it makes these two pieces congruent. Okay, and these two pieces congruent. We definitely would be able to write some equations with that. But I want to tell you about another relationship that I failed to tell you about, mid-segment. And so I want you to go back to your mid-segment notes and add this to a characteristic. What we find is the mid-segment is half of the third side. Okay, so let's call this DE here. Okay, so it's half of DE. Okay, so basically what I'd say is I'd set up an equation. The mid-segment is half of that third side, the side that it doesn't touch. And if you think about it, it really makes sense. You know, you could pick up that piece up and put it down there and find that it is about twice as big. Okay, so there's my relationship. I'd solve that equation and find out what x is. Let's go on to the last one here. Or almost last one. Given AD is a mid-segment, write an equation to solve for y. So in my haste, I'm trying to get this done. These are y's here. Very good. Okay, they're angles. So we learned in the characteristics of mid-segments that they create parallel lines. So if you look at it, I have this parallel line and this parallel line. Draw this over this way. And then we have this transversal, that one side. Here's the mid-segment D. And so we have this angle right here, which is this angle right here. And then we have this angle right here, which is this angle right here. And we should recognize that those are consecutive interior angles. And what we know is consecutive interior angles are supposed to be what? See if you can get it before I get to finishing my equation. They should be supplementary. Okay, so we can write relationships between those angles as well. All right, and then finally, here we are, the last one. We have given AD as an angle bisector. Okay, an angle bisector, another angle bisector. problem. So there's those congruent. And what we found in our characteristics is that it created proportions. And so what we want to do is write a proportion. A fraction equals a fraction. See if you can write the proportion that makes sense with these four pieces. Okay? Go back and look at your notes and make sure that you're doing something correct before you go do something wrong. Okay? So I'm going to write the proportion. You can put me on pause, come back and check me and see if you got it. I have x over 18 equals 12 over 10. Okay. Another idea could have been this. I could have done 10 over 12 is equal to 18 over x. In either case, I know that when I cross multiply, 10 is going to still multiply times x. And 18 is going to multiply times 12. Okay? So that's how you're going to solve those. All right, that's all I have for you. There's three simple problems that you should be able to use my example problems to get you to it, as well as the characteristics of these things, okay? Three simple problems. Make sure you draw the drawings and write out what the question is. It's otherwise, if you just give me answers, that's zero, okay? Don't forget to put your name up the top right-hand corner with your period name, as well as the title across the top. Fantastic. Here you go. Have a good one.